Welcome to my video course on Communications-Based Train Control, CBTC. I am absolutely thrilled to have you here today. So, if you've ever found yourself wondering how on earth modern rail operators are handling these massive increases in ridership without, constantly laying down new tracks, well, you're in the exact right place. Today, we're going to unpack the digital revolution that's literally happening right beneath our train cars, and we'll explore the core capabilities transforming global transit as we know it.
All right, let's define exactly what we're talking about here. CBTC is a continuous automatic train control system. Now, the absolute key phrase you need to focus on is independent from track circuits. You see, historically, railways relied on these fixed physical track circuits just to know roughly where a train was located. It was a very mechanical, kind of rigid way of operating. But with CBTC, this technology fundamentally changes the game. It changes how we track and manage trains entirely, moving us away from those old physical circuits and replacing them with highly precise, continuous, bi-directional data streams flowing between the train and the wayside.
Here's our syllabus for today. 1. Understanding CBTC basics. 2. Maximizing capacity and headway. 3. Enhancing rail safety. 4. Driverless operation capabilities. And 5. Energy efficiency and sustainability. Okay, let's dive right in.
Module 1. Understanding CBTC Basics.
Now, what's really interesting about this slide is how it visualizes the invisible. We're talking about real-time, bi-directional communication constantly happening between the trains and wayside radio towers. In a modern system like this, a train isn't just some heavy vehicle anymore. It's actually a highly intelligent rolling computer. These trains are continuously calculating and transmitting their exact status, their precise location, and their braking curves directly back to the network. The system literally knows exactly where everything is at all times. It's a real game changer. Let's move on and see how this builds into our next major operational advantage.
Module 2. Maximizing capacity and headway. So the primary reason rail operators across the globe are adopting this system is simply to make significantly better use of their existing tracks. The absolutely crucial point here is understanding the difference between fixed blocks and moving blocks. Traditional signaling uses fixed blocks. Imagine, if you will, keeping an entire empty street between you and the car in front of you just to be safe. I mean, sure, it works, but it leaves a massive amount of unutilized, wasted space on the track. CBTC introduces the moving block system. Because we have that real-time data we just talked about, the safe train separation distance fluidly moves right along with the train. It acts exactly like advanced adaptive cruise control on a modern car, which allows for much closer yet completely safe headways. And, we really need to connect this brilliant engineering directly to the passenger experience. Tighter headways means operators can run way more trains on the exact same physical infrastructure. For us, that means faster services and way less waiting around on the platform. Plus, because that location data is just so incredibly high resolution, those real-time passenger arrival boards you see on the platforms, they achieve pinpoint accuracy. Ultimately, you get a smoother, more consistent ride, and rail operators maximize their capacity without pouring a single ounce of new concrete. How cool is that?
Module 3. Enhancing rail safety.
Naturally, when you tell someone you're running massive trains closer together and at higher speeds, their very first question is going to be about safety. But here's the thing. Increased capacity never, ever comes at the cost of passenger safety. In fact, safety is drastically enhanced here. I want to quickly walk you through these critical automatic train protection, or ATP, functions. This system provides guaranteed collision prevention and automatic excessive speed regulation. It is constantly calculating and maintaining guaranteed safe braking distances for every single millisecond of the journey. It even handles program stopping, precise door control, route interlocking, and absolutely vital work zone protection for track workers. And listen to this. If a speed limit or a distance safety threshold is ever breached, the system doesn't sit around waiting for a human to react. It will automatically apply the brakes. It's basically an infallible digital safety net.
Module 4. Driverless operation capabilities.
Let's shift our focus to one of the most futuristic and honestly transformative aspects of modern rail systems made possible by this tech. CBTC enables different grades of automation, or GOA. Let's look at how this progresses. Step 1 is automatic train protection, which is basically a safety override for manual driving. Then Step 2 introduces partial automatic train operation. This is where the system actually takes over the physical driving to maintain perfect scheduling, while a human driver stays on board just to monitor things and operate the doors. But Step 3? That is where the magic happens. Full driverless operation. Here, the system completely handles the driving, safety detection, and door operation. It can completely replace manual driving, which entirely removes human error while maintaining those incredibly strict safety standards we just discussed.
Module 5. Energy Efficiency and Sustainability.
Let's take a look at the often hidden financial and environmental advantages of upgrading to this digital rail infrastructure. And this brilliantly illustrates the interconnected architecture at play here. You've got the automatic train supervision, the data communication systems, the wayside, and the train-borne systems all working together in perfect unison. Because this whole architecture relies on streamlined digital communication, it drastically reduces the need for clunky, heavy physical trackside equipment. And less equipment? Well, that means it's much easier to implement, it significantly lowers maintenance needs, and it vastly reduces both capital and operational expenditures for the entire rail network.
But hey, the benefits aren't just financial, they are deeply environmental too. This system eliminates all that unnecessary manual acceleration and harsh braking. The automatic speed regulation acts as this incredibly efficient digital driver. It completely smooths out the ride, which totally optimizes energy consumption and saves massive amounts of power over time. And think about it, when you reduce power consumption on a mass transit scale, you are dramatically reducing overall air pollution and enhancing the long-term environmental sustainability of the entire city. It's a win-win.
So, as we wrap up, I want to pose this rather provocative thought to all of you, my students, today. With trains running closer, faster, safer, and entirely without drivers, how will this invisible digital infrastructure reshape the future growth of our expanding megacities? Really think about how these hidden technological benefits scale up. Because solving our massive urban population challenges, it isn't just about building more trains, it's about making the infrastructure we already have infinitely smarter.
Things we can see in next video.